Hello, my name is Alexa, and my Module 2 presentation is on whether students' GRE score predicts their first year grad school performance. So to start off, this is what our data represents, and we can see that these items over here correspond to these supposed questions on the GRE, and we also have some other items that we can look at. So to begin, classical test theory is described by the equation observed equals true plus error. And the purpose of doing this basically is to understand more about the observed score, and we can also use this knowledge to understand, what we're examining. To begin, we can examine Cronbach's alpha and calculate this. So in this instance, it is important to note that we want to use raw alpha because the items are not standardized. If they were, we would use standardized alpha, but that's not the case here, and that is according to Carmines and Zeller. So Cronbach's alpha, though, is a measure of internal consistency, and we can see over here that our raw alpha is about 0.8, which is a good alpha level and indicates very little variance specific to individual items, according to Cortina. But what does this really mean? So over here we can look at the reliability if an item is dropped. So we can, for instance, go over here and look at x5 and see how it significantly affects the alpha level. And so this tells us we may want to remove this item from our data set, and we can do this for all of these items and see how they affect the alpha score. Next, we can look at inter-item correlations further, and we can see that we have some strong correlations over here, and then not so much over here. Next, we can examine criterion validity by looking at this year's GRE score versus last year's. So it's important to note here that our p-value is greater than 0.05, so the criterion validity for this year's GRE is quite low. And so if we know that last year's GRE was up to the gold standard, we can say that this year's GRE and last year's do have a pretty large discrepancy, and so therefore this year's GRE is less valid. Next, we can assess individual questions on this year's GRE. So for instance, we can look at first year grad school GPA and a reading comprehension on the GRE this year and find a kind of a moderate correlation. Or we can look at first year grad school GPA and a calculus question and find no correlation. Or we can look at first year grad school GPA and a statistics question and find a strong correlation. So we could say that performance on the statistics question on the GRE is very correlated to first year grad school GPA. Next, we can go into hypothesis testing and conduct a bivariate t-test. So our null hypothesis in this instance would be there is no correlation between this year's GRE score and socioeconomic status. And as we can see, our variables corresponded to this year's GRE and socioeconomic status. And since our p-value is greater than 0.05, we fail to reject the null hypothesis. However, we can't just take this as the final truth and make hasty assumptions. Even though we fail to reject the null hypothesis, all we can really say, and this is a quote from Cohen, that we can be pretty sure of the direction. For example, A is larger than B. And those are my hand calculations, and that is all I have. Thank you.